heat interface units, HIU. My name's Alan Hart, and in today's video I've got David here from Vokera by Riello, and David's going to go through the heat interface units for us, which is a little bit like this. So heat interface unit, HIUs for short, and how do they work? Also some problems that you might have with them. So what I'm going to do is I'm going to show you David's part of it first. David's going to go through the unit, talk about all the pipes and all the components inside, and then afterwards I'm going to do a drawing like this and try and simplify it for you, just to hopefully help you understand it. So yeah, let's if you can, please put a thumbs up on the video. It really helps with the video, and also if you could add a comment below as well, that also would be good. So first of all, let's go over to David, and then we'll come back to me, and then we'll chat a bit more about it.
Thank you, Alan, for this opportunity to talk about the heat interface unit, HIUs for short. We've spoken about these in the past, and I know you thought it might make a good addition to your channel if we can explain to guys what actually that unit is. Here's one behind me here. This would sit in an apartment or outside an apartment or property, and it sits between a district or communal heating scheme with main plant and between the end user. So what it is I describe it in a way, it's a combi boiler because it heats the hot water and heating, but there's no heat exchanger in it. The primary flow and returns from the main plant in a boiler house somewhere are taken into the heat interface unit, and there the water usage and the heat usage is monitored and metered, so the end user pays for what they use. So this is our unit here. This one is our indirect unit, has heavy insulation over it. I'll remove the insulation to show you what's inside. It looks quite intimidating, but basically we've got two sections, a domestic hot water section and a space heating section. As I'm saying, this is an indirect unit. I'll explain the difference between this and a direct unit later. But I'll quickly run through the route the water takes through the units. So you've got to imagine an apartment block with a pipework duct up it, and there'll be cold water, so fresh cold water, a primary flow and a primary return to the main plant room. Everything else is done here for that particular apartment or house. If I do the cold water first, so domestic cold comes in. There's a spacer here where a water meter could be fitted, so the apartment user, householder, could be billed for the domestic cold water use and hot water use. And from there, there's a T, difficult to see, but it is then routed out to the cold taps in the apartment, but also into the domestic hot water plate heat exchanger here. It passes through the domestic hot water heat exchanger, being heated by the primary water from the main plant somewhere else, exits to the domestic hot taps. The flow rate on this particular unit can be up to 22 litres a minute. It depends on how much cold water there is, depends on the power of the unit you choose. So that's the cold. The primary flow, the hot pipe in from the main plant, is here. So the primary flow comes in here. There's a filter. Please ignore this filling loop because this is a continental model. We would use a standard filling loop as you're used to in the UK with a flexible hose for the UK models. But primary flow in, the temperature is sensed here. This is a sensor, and then the primary flow is split. One side goes over to the domestic hot water plate heat exchanger, and the other to the space heating heat exchanger. Now must remember, the primary flow from the main plant is active at all times. So these plate heat exchangers are up to temperature at all times. So there's no lag, as in the combination unit. When you open a hot tap, you fire the main heat exchanger, have to wait a while the main heat exchanger transfers its heat to the plate heat exchanger before you get any at the tap. These plate heat exchangers are hot all the time, so there's no delay. So the primary flow comes in, heats up the domestic hot water. There's a sensor on the domestic hot water outlet from the plate heat exchanger, just under my finger, and that sensor acts upon this valve here. This is where the temperature of your domestic hot water is selected. The thing to bear in mind, I'll come back to this later, this is a proportional valve. It's not simply an on-off valve. So, cold water in, heated up by the primary water in the plate, hot water out, primary water in, primary return out to this proportional valve, and then back down to the return through the heat meter here, back down to join into the primary flow returns around the building. The central heating is controlled in a very similar manner. So primary flow in, the temperature of the space heating is controlled by a control here, sensor located at the back at the top, and so that would be the control of the temperature of the water to the space heating system. The pump for the space heating system is here, and we can incorporate mixing valves, motorized valves, blending valves, a room thermostat, a modulating thermostat, weather compensation to control the output into the space heating, whether it's underfloor or radiators. The thing I'd like to point out now is we've got a proportional valve here and a temperature control for the flow to the space heating. Because the primary flow returns are obviously controlled by the main plant room and will be at high temperature, if the domestic, one way it scores points over a combination boiler, if the domestic hot water demand isn't particularly high, maybe a shower, maybe just a basin running, all of the water that's available for heating the plate heat exchanger would not be used, because the energy in that is more than enough to satisfy the domestic hot water usage. So the proportional valve here will allow some circulation through the space heating, so there's actually simultaneous, possibly simultaneous heating of domestic hot water and space heating. The return waters are taken through this device here. This is the heat meter. So what we've got is a flow temperature coming in, the return temperature sensor, which is at the back of the heat meter, and there's also a flow meter. And with those figures, it can calculate the amount of energy consumed by that property. So the customer will pay for what they use. There's also a differential pressure valve here, and what that's used for is to balance each heat meter, the flow return through each heat meter in the block, so each one is apportioned the right flow. HIU unit. Expansion vessel is here for the space heating system. I'd just like to go back and mention a direct unit. This is an indirect unit because the heating system is indirect to the main flow returns, as is the domestic hot water system. There are direct systems, and that means this side of the HIU would remain unaltered. But on a direct system, we don't have a second plate heat exchanger here. The primary water that is circulating around the apartment block is circulated into this section, but there's no plate heat exchanger. So the water that circulates throughout the building, throughout the space heating in that building, is at the same temperature as the primary water in the main flow returns. Now that limits what you can do. It's obviously going to be operating at a high temperature because the water's had to travel some distance from the plant room. So you'd be restricted to perhaps using low surface temperature radiators or putting mixing and blending valves in beneath the unit to make sure that the surface temperature of radiators or underfloor heating would be at safe levels. But as I say, this is direct. Now the heat meter can be read at the point of use. They can all be linked to a main data reader somewhere in the building and a laptop, or they can be linked to GPRS, so a building manager or energy management company can monitor each unit individually from another place. Why are they appealing? For social landlords, for buy-to-let landlords, it means there's no gas in that building. The gas could be in a plant room someplace else, maybe in a basement. There's no need for a buy-to-let landlord to have a gas safety certificate every year. There's no stored water in a hot water cylinder in an apartment because everything is heated at point of use. If it's architects do like to make attractive buildings. If it's an attractive building, there's no need to put flues through the wall. And if the boiler goes wrong in 10, 12 years time, there's no need to get access to a high-rise building to replace that boiler, replace that flue, because the facade of the boiler is unaltered. So it does offer quite a few advantages to developers and landlords. For guys at the other end of the spectrum, like me and you, we work on the tools. It's something else to master and to understand how they operate. And I hope this brief explanation has given you an idea of what these units can do. Usually the guys like me, the first thing or second thing we want to know is how expensive they are. They're around the same price as a combination boiler. But you haven't got gas in the building, there's more security to that building because you're not having more engineers going in and out of the building. And the other benefit is that we use these in some posh apartment blocks in the southwest of England. We would use this fed by perhaps a cascade of boilers. So there's backup on the boilers. If I can ask Charlie, our cameraman, just to show, this is one of our cascades. We can obviously have many boilers in our cascade. So we would use, what we've got is a cascade of boilers providing the main source of heat. If you can pan across, Charlie, we would use something like a thermal store. So that would be the thermal store of water, so the boilers don't operate continually. It builds up in, the heat energy is stored in a thermal store. And of course, for some developers, that gives them the opportunity to have more than one source of heat. So you could have gas boilers, a solid fuel boiler, an oil boiler, solar panels, all putting heat into a thermal store, and from that thermal store, the primary flow and returns or communal flow and returns would be distributed around the building, and it becomes easier for developers to manage the energy supplier and choose an energy supplier that's giving you the best deal at the moment, whether it be oil, LPG, natural gas, whatever. I hope that was of some use, and thank you for the opportunity.
Thank you very much for that, David, and thank you to Vokera by Riello for giving us the opportunity to have one of these videos to share with the people on this channel. What I'm going to do now, I'm going to rub all this off here, and I'm going to go through the plate heat exchangers on it, and I'm going to try and explain a little bit how I understand that it works. Now, just to bear in mind, as I always say, I am not a trainer. I'm just trying to help the new trainees, or even some of the people that's been doing the job a long time that don't understand things. So please, by all means, put some comments below and correct me or whatever. But yeah, let's wipe this off and I'll explain how I understand this works. Right, okay, so what's all them pipes underneath? There's a lot of pipes there. So this is the way that I understand it. So we've got your cold mains coming in. So if it were a normal property, that'd be coming in from your street, and whatever they call that pipe, might be supply pipe, whatever. But your cold mains coming in, and that's coming into property, but it's going into this box first, and it goes to a water meter. And then you've also got your hot pipe there. So that one goes to the hot taps. Cold going to the cold taps, because remember, the water coming in needs to be on a water meter, so you can be charged for it, because this would be in like flats or whatever. So that's cold, that goes to your taps, to your shower, whatever. Return, so return and flow, so from your plant room. So if it's got a massive plant room somewhere, then that's the pipes. That's your main flow and return, if you like, and that'll feed all the rest of flats in building, or most of them in building. And then you've got your return and your flow as you normally would on your central heating system. So now what I'm going to try and do, I'm going to try and explain how these build up to the different components on here. So first of all, we've got plate heat exchangers in this one. So we've got 2 plate heat exchangers. And what do plate heat exchangers do? They transfer the heat via the plates. So what we're trying to do in this particular case is, when this cold water comes in, it goes through the plate heat exchanger, it gets warm, and then it goes out to the hot taps. So just to try and explain this a little bit easier, so again, we've got the cold mains coming in, goes through the water meter, it's got a T on there, one side of it goes to the cold taps in the property, and then one side of it goes to the plate heat exchanger. So that's your plate heat exchanger. And then the other side of it, so this goes through here and it comes out here hot, and then that side of it goes to the hot taps. This side of it, this is your main flow, so that's coming from your plant room, so that's your main flow, and there's going to be valves and stuff on here, but I'm just trying to simplify it so you can understand what's happening. And then that's going through the plate, and then once that's cooled down a little bit there, it's took the heat out of it and gone to your hot tap, or took part of the heat out of it. Again, that's going to go back to your plant room, and again there's going to be some more T's on this shortly, but I'm just trying to do it so you can understand it a little bit better. So what that plate is doing, it's transferring the heat from the plant room into the water that's going to come out of your hot tap. But what you don't want to do, you don't want to be opening your hot tap and getting water from the central heating or from the plant room coming out your tap. So that's why you would have a plate, or that's one of the reasons you would have a plate on this. So that doesn't mix. So now what we'll do, we'll add this other plate heat exchanger up here, and I'll try and explain that one in detail if I can. So we've done the hot water side, and now we're going to do the heating side. Now, just to bear in mind, I've just tried to simplify it a little bit on here. So we haven't put the controls in, I haven't put any of the temperature stats in. David's already spoken about them. You can also download the instructions for this online. But what we've got now, so you've got your main flow from your plant room, and one side of it's going to this plate, as we've already spoken about. But then we've got a T on it, and one side of it's going to the heating plate heat exchanger, and that just works identical really to the hot water one. So you've got your main flow going round the plate, cools down because of the water in the central heating system, and then that goes back to the plant room on the return. And then this side of it, all you've got there, it's just like a normal heating system really. You've got a flow and return into there. On this particular boiler, it seems like the pump was on the flow. It may be that on some systems it might be on the return, so maybe you could have a pump on there. Obviously in boilers usually the pump will be on the return in the boiler here. So I hope you can understand that part of it now. On this side of it, we then need to put the pressure up. So we need to top it up, and also we need to top it up, and then we also need to we need an expansion vessel. So this is where the expansion vessel comes in. So what I'm going to do now, I'm going to cut this part of it off, and we'll draw this again here, and then we'll start adding the components then for this part of it. Right, I'm not the best at art, as you'll all know already. So I've just tried to move this over now and explain this a little bit better for you. So again, that's your flow and your return. They go to your plant room, but then this is the flow and return now for the central heating part of the system. But then what we need to add on to it, we need to add an expansion vessel, and that'd be sized in accordance with the size of the property as normal, like we would with any expansion vessel. And obviously that connects onto the system. Normally, it's probably going to be, it might be on the return. On this one, it looks like it's on the floor, but it's hard to tell. I've not seen one of them units in person. So it's more likely to be on the return. So that's the expansion vessel. You're also going to have your pressure relief valve. So if there were too much pressure in it, it'd have somewhere to blow off to. So you're also going to need that. The other thing you'd need on this, you'd also need a filling loop. And as David's shown, that they had a built-in filling loop, so you'd have a filling loop similar to that. And what you'd do, you'd top it up as normal. There'll be a pressure gauge on. You'll top it up as normal to whatever pressure they say is the correct pressure. It might be 1 bar. And then once that's up to pressure, then that's just the same. It's just the same as any other heating system where you can go around and bleed your radiators. So potential problems with this would be, people's gone round, they might have taken a radiator off, put the radiator back on, and then it's not working very well. So it could be that there's no water in it and it just needs repressurizing. So that could be one problem with it, or one thing with it. Another problem could be a plate heat exchanger blocking up. So if these start to get sludged up, depending on where you are in the country, they could also get scaled up as well. So the hot water side, that could get scaled up in some parts of the country, but the central heating side, or the plant room side, if you like, that could get blocked up on the hot water one, and also on the heating one, it could get blocked up on both sides, because they're both sort of system water. They're both water that's recirculating around. So on the plate that's used for the heating side, if the radiators will still need protecting, so like putting your inhibitors in and things like that. So that would be on that side of it. Yeah, I hope I've tried to explain this in the best way I can. The reason you'd have this type of system would be, a lot of times nowadays, as David had said, they might be trying to use new technologies. They might be having biomass or solar or whatever. They might have plant rooms. They might have a good thing would be, if you've got a big massive plant room and one of the boilers fail, then they'd have backup boilers. So you're never really going to be without hot water and heating with this type of system. Obviously this is it's not a system that's going to be used a lot, you know, in comparison to such as like combi boilers and things like that. Yeah, so as I said, and as I always say, I'm not a trainer, just trying to explain things how I understand it. I'm dyslexic, and I find that if I do things like this and I draw things out, I can understand things better. So hence the reason I do this type of thing. Yeah, I hope it's been helpful. If you've got any comments, please put them below. Please thumbs up, like, share, all that good stuff. And thanks very much. Thank you to David from Vokera. Yeah, thank you.